So in this section, I will introduce the data analysis. So once you set up your device and make some measurements, you may take a chance to analyze the data by yourself and see if you find anything interesting. So I will let you know how to download the data and make some plots. So in this section, I will show you the database for storing the NSP data, and I have some examples of basic analysis, such as performing statistics, and I can show you how to analyze the time variation of NSP, short-term or long-term, and the geographical variation of NSP. That means we can compare the line curve across the system, across different cities. And all the data you submit to our server will be stored in a database called IYL. The name of the database is IYL. And this data, you can access this database from the web browser. So you don't need to install any software. And you can you can go to this database wherever you have an internet connection. However, the IP address and the login data is not available now because the database is now under development. But we will soon to launch the database, and then I will let you know the details. So for your information, the database we use, the management system is called MySQL. I'm not sure whether you are familiar with this management system, but it is a very common database in the market. Actually, it's free of charge and open source, and it can handle a large number of data. Actually, our last project, NSN, used this kind of database as well. And this page shows you the structure of the database. It has 3 tables, serve different purposes. The first table is called SKML NSP data table, which stores the NSP data from all stations in real time. So that when you check this database, you refresh it, you will see the database size change because the data from your device will fit into this database. And there's another table called long night sky event and long night sky events category. As I said yesterday, and it's important for all of us to have a good record of long night sky events. So these 2 databases show the details. And normally you can access the long night sky event database and add some fields and add some data to this database. As I said before, it really depends on your contribution to this table. So I will show you how to do this. Okay, for this workshop, I will have a training database for all of you. So if you have a laptop ready, please go to this address. And log in as this username and password. I do this here. So you type in this address in the address bar, and you can see something like that. Okay, can you do that? If you have a question, just let me know.
Maybe I should.
Oh,
You should write.
Oh, sorry. Okay, I have to show the slide again.
So is it 1, 2, 8, 1, 1, 99.220.71 slash IYL
admin.php. Actually, in the handout you got yesterday doesn't contain this information because you join this section, then we know the details.
Okay, please try to log in this one and try to work it together.
Can you see this one? Yes, I think so. So you click login. You should see something like that. Then, as I said before, the database we are using is called IYL. Click this. Then you will see 3 tables. For the training database, they have the same structure as the real one in the future. So probably this training database will keep online for a period of time so that your partners can use this as a training. So since this is a training database, it stores no real data, but I load some old data from our previous survey to the training database so that you can pay them. And you see that we have a huge number of entry from 2 stations in Hong Kong. They are HK1 and HK2. So they cover several months. So that we expect that this data covers different lunar cycle and different weather conditions. So it's quite similar if you have the data later. Also, I load data collect from here and Taipei in the database. Can you log into the database? So in the table called SQMLE data tables, which contain the raw data, and each entry has the following fields. Each entry has the following fields, which tells us the properties of the data. So we see the ID is the ID for each entry. And actually, not all fields are important for you. Some of them are for our debug and for programming. And so only the following fields are useful for basic analysis. They are ID, they are the unique ID of each entry. And the receive use TC is the time in time format. YYY is year, MM is month, and DD is day, and hour, minutes, and second. And they are the time and date and time of the NSP data in UTC. Because this network consists of stations in different time zones. So we use UTC to represent the observation types of each data. And again, we have another time field for the same for the data, observation time and date, but in local time according to your station. So if you set up a station, as I said yesterday, I will input some information related to the station, like the location and the time zone of the station. So we do the adjustment of the time zone. So these 2 entries are basically the same, but in different time zone. So the NSP is the raw NSP data measured from the sensor. As I said, the raw data, we should pay attention to the raw data because this contains different contributions from different components. And the device code is the information about the location of station. I will give the station code to each of you because this station code is unique for each location. So it consists of 3 to 4 letters to indicate device. Also, the last one is so-called status. This is for our programming. It has two options, success or fail. So you should always select success. So before I go to show you how to download data, we discussed the long night sky event yesterday, and now I will show you how to submit a record for long night sky event to this database or to the database in the future. So if you log in the training database, you see three tables. You may refer to the slide used yesterday. Sorry. This one, the slide called Long Night Sky Event, the presentation called Long Night Sky Event, and go to page 8. So let me repeat, you are all invited to maintain a good record of long night sky event in your location. So how to do that? You see the long night sky event table, then click a new item and input some information. Let me do it together. Actually, you can input something because it's a training database, so it's just for demo station. You click this table, long night sky event training, then you see this one, and you add a new item. Click this. So you need to try to input something. I show you an example first. What that field means. The ID, the first, this field means ID, and you no need to touch it because they're generated by the system automatically. For the site, that means the location code of the station you are reporting, and the start daytime and end daytime category. Start daytime means the event start time and end time in the local time. Okay, this is convenience for you. And for the category, there are few choices. This category tells us the nature of the long night sky event. There are 9 main categories, like this. Each ID consists of 2 digits, and the first digit tells us the nature of the long night sky event. For example, category ID 10 to 90 represent the long night sky event related to installation. And this related to network, power, mounting, maintenance activities, astronomy, weather, or others. So that means if you report some long night sky event related to power supply, you should input something start with 30 to 39. So as the last categories of each main categories, for example, 39 represent the other events related to power supply. I show you examples. So how to get this? How to get the list of categories? You can go to another table called long night sky events categories. Let me go back. So before you create a new record of long night sky event, you should check the category first. This one, I add a training at the end of the name of the database to indicate that it is not real record. So we click this long night sky event category training and click select data. It will list all the category available for you to choose. I sort the category by the numbers, so you see that? So you see that under the category of 1, you see that 1 will represent insulation, first light, something like that. And if you have power problem of your 31 because it's what they mean by partial. Partial is mean the events only affect your station, not all the station. We serve categories called 32 to means that all the power supply goes down, or the power supply for the Earth goes down. We use 32, but I think it's never happened. But if your power supply of your station terminate for some reasons, for example, we choose 31 because a partial failure related to your station only. You see? So I think most likely you will input something like under this category 16 because if there was a stargazing event in your location, I think so, it's related to certain activities, and they are the stargazing parties, so you should select 61 as the categories of the night sky event. So let me go back. Please note that this table will be updated from time to time if I have new choices or new choices of events. This categorization based on our past experience running in Hong Kong, so it may not fit all the situation. If you find it, you can't find a good description of your categories, you can select others. For example, there were some activities in your station, but they are not. They are either stargazing event or private observation. So you select others. It takes some time for you to select the good categories, but it helps us to do the analysis later. Why? Because later when you are going to analyze the data, you may set different criteria to filter out different kinds of long night sky event. If you think the activities is acceptable for your analysis, you think that they will not affect your light curve, or on the other hand, you want to study how the activities, stargazing activities, affect your data, so you can just select the data taken within this type of time period. So it's useful for all of you. So the last there is a field called reading effect for each entry. What's that? Reading effect has two values only, yes and no. This tells us that whether the NSP data were affected by the long night sky event. You have to decide when you input the record whether the readings will affect a lot. Let me show you an example. Suppose in a public event, the lighting of the rooftop of the SQME is installed or turned on. So clearly, the data collected within this period of time will be affected, right? So in that case, you should select yes for the field reading effect, because clearly the readings were affected. On the other hand, for example, if another observation section, the external lighting will not turn on, so the data will not affect, so you select all low. So what is the idea with you may ask, I'm sure that the data are not affected, so why you need to input the record? It's for our information. It's a good record of all the long night sky event of every location. If you analyze the data and you want to eliminate all the possibility of the long night sky event, you can filter out the event, filter out the data taken during the long night sky event, even though the data will not affect. Okay, so it depends on your analysis. Another example is that you will mount your SQMLE and you find the mounting is not very good, so you remount the system in daytime usually. So you can input the long night sky event for this mountain, but clearly the readings will not affect because you do it in daytime, but so you select low for this field. So I show you examples. Suppose there was a sky gazing event last night from 8 to 10 p.m. So the station code is AOJ, stand for the station you visited yesterday. And the start daytime and end daytime in local time is something like this. Please note that even though the event starts at 8 p.m. and end at 5 p.m., normally I will extend the long night sky period by 30 minutes before the event, before the start of the event and after the start of the event. Why? In my case, at least in Hong Kong, if the stargazing event starts at 8 p.m., someone will go to the rooftop and turn on their light for setting telescope or other equipment for the people in the stargazing event. So we reserve for 30 minutes for the preparation time and another 30 minutes for the time you tidy up, take the telescope and something like that. So it's just a safe precaution because as I said before, someone will turn on their light earlier before the start of the event. So in the detail, you input something, you can type as much as you can. But the idea is that we know what's actually happened during that time period. Okay, so you can say something a public stargazing hosted by someone and the external lighting turn on, and some with mask, the field code with mask, you can say the rooftops is the same as the SQMLE installed. Okay, lastly, you select data, the system will ask you whether the reading were affected, so you select yes or no. In this case, yes. You can do it together, or you can create some long night sky event. So we go back to the long night sky event training database. In the future, you should see the same database without the lamp training, but they look the same. So in this slide, you click new item and input something. Maybe you can follow my examples here, or use another example you can think of.
So what's the difference between the detail and the remark?
And this is a good question. And for the details, it belongs to you can say more about the long night sky event, because if you show us only 61, we know that is activities related to the public stargazing, but you may tell us that the external lighting will turn on in the fields of details. And for the remarks, you may give additional information, additional to details. So it's like that the rooftop as SQMLE installed to indicate that the lighting turn on. The lighting actually turn on was located near the SQMLE. So lastly, you select yes for this event and click save or finish. Okay, do that. You see that in this training database, there are a number of fields already there. I do this for demonstration. You see that, like, there are 23 events in this database, and two of them are probably imported by me. How about yours? You can do this. Don't worry if you make a mistake, because it's just a training database. The idea is that you know how to report to us. Actually, this page can be filled by everyone, so that if you are doing analysis on the station other than yours, you can check their station code and check whether there is any long night sky event during your analysis period. Okay, I think this is easy for all of you. And as I said before, if you are not sure whether the long night sky event will affect the light curve, this also lets us know and provides the details of each event. And if you find a characteristic, if you can't find a characteristic that fits the nature of the long night sky event, you can select something like 9 represent other event represent to that main characteristic. Okay, you are wise to make a record as soon as you know it, even though it's not happened yet. For example, we schedule a number of public stargazing events in the coming few months. You can still input the record. Okay, or on the other hand, if you know the event that happened last night, you may make a record today. We even accept the daytime events. As I said before, they will not affect the NSP light curve at all, but it's good for our record, or even it's good for our debugging. When we find some problem of at some particular site, we will sometimes look for the long night sky event happens in daytime. So it helps us to keep good maintenance. So as I said, you can check the night sky event provided by others. And so in your data analysis, you should remove or filter the data taken during the long night sky event before analysis. Otherwise, your conclusion may be wrong. So any questions on the input of long night sky event? So we go back to the train analysis section. Am I right? Or this one? So before you are conducting the analysis, we assume that in this section, the data taken to long night sky events will be removed, and the sunlight effect data will be removed if necessary. And in this section, I will show you how to exclude the non-physical NSP reading, something very large or very small. And we will not consider, because we don't have enough time to show you how to remove the moonlight contribution, the scattered city light from cloud, and the aging or other optical problems. And in this section, I won't show you all the possibility of data analysis. They are based on our past experience. I believe that if you have some experience in data analysis of light curve or other astronomical objects, or or even though some students here did an excellent job in analyzing light curve. So I think I can only provide the basic concept to you, so you can do your analysis whatever you like later. So the adminer, the platform for you to access the database, has some to provide some built-in function to perform the basic statistics. For example, you can ask the examiner to calculate the average of NSP and count the number of entry of your sample, which we belong to the sample size, and you can count the distinct entry of some fields, and you can ask the examiner to report you the maximum value of NSP and the minimum value of NSP easily. So this is examples, and we can do this together. Because suppose you want to find the sample size from this station between this time period. What should we do? We go to the database, go back, call SQLE NSP data table, this one, and select data. You see that there are many data already there. So back to our examples, we want to find the sample size of this size between this time period. So we select count to report for reporting the sample size, count ID, then click search. Search, you have a number of options. You are looking for the station AOJ, so you define the device code equals to AOJ, and the time period at which is received adjust. That means the observation time in your time zone. So you select bigger than or equal to some time period. What is the time period? So these are called function, and the entries under the search are called condition. You set the device code equals to this station and the time period between these two time periods. The order of this condition is not important in this case. Please look at one more condition you have to check is the condition to remove the unphysical NSP readings. You see that I said yesterday the unphysical reading I define here is greater than is smaller than 10 and greater than 20 feet. So you are counting the sample size of physical reading, not unphysical reading. So you exclude the counting for unphysical readings. So you just include that the NSP reading greater than 10 and smaller than 20 feet. So after you set all the parameters, just click this select. It will give you an answer. Okay, do that. I think it's not difficult. And the result showed here is 720. That means within this time period, at this location, we have 720 physical reading. Okay, this is sample size in some sense. Actually, you can try different locations. We have 4 locations here: AOJ, TAM in Taiwan, and HK1 and HK2. You can try different options. Don't worry, we won't hurt this database. Use IYL training username and to log in, you can't edit the field in this NSP data. Actually, this is the data for training. You can do anything you like. Don't worry. So example 2. The idea is similar. We want to find the average NSP collect from this station between this time period. So the conditions are mostly the same. You may try here now, or we try later. You see that we also need to remove the unphysical readings like this, and we got a result. Please look at the result. Look at how many digits we have. We have many digits for the result after the decimal point, but in some sense they are not meaningful because we can't do such kind of accuracy in our measurement. You will see that the accuracy of the SLE is about 0.1 millimeter per second square. So the digit beyond the second digit is meaningless. It's just the output from the system, calculate the average. Okay. So let me move on to the next examples. Is after the basic analysis, after the basic statistics, you can study the time variation of NSP like this. For example, we want to study the light curve here between this time period. So you do this. For the fields, since you want to have the raw data, so you don't need to select any function, or you have to select or display the observation time which is received addressed and the NSP, these two. Then we define the stage location and the time period as before. Okay, for the range of NSP value, I would not set the lower limit of NSP so that you can see the zero reading will comes out like this. Also, you will need to sort your result according to time. So, because we are looking for the light curve, right? So we select the sorting by which one? By time received addressed like this. Okay, do that. So we click select. Then you have many rows of data sorted by the time field like this. You can't sort in one page, so you need to click to another page for the rest of the data. If you want to export this data for your analysis, you can click this export here. Export, then you have several choices. For example, you can open, save, and save it. But normally we use save options. And save what? There are 4 different kinds of formats you can choose. For the first one, SQL is just for the system MySQL. So normally we don't use this. And CSV format and TSV format. Normally we will select CSV. So we can export. What we get? It's a CSV file, same as the result shown here. Okay, we open it. You see, this is these are the results according to your selection or condition, right? So what should we do? The rows of a winner ends here. So it's up to your decision to how to analyze the data, right? But in this section, I will show you an simple example to plot the light curve of this data using Excel. You can use another software you like, but as I want to show you examples, I use Excel. So I hope you have some experience in Excel. So these two columns show the observation time and data. You see that, how many data we have. These data were taken every 1 minute. So you see that we expect the readings for every minute, right? And in our case, the standard observation interval will be 30 seconds. So every 30 seconds, we should expect a reading. However, in this format, in the display shown here, we can't see the second information. So if you want to check the receive time of the receive time in second of this entry, we have to change the display format. But I won't show you the details on the use of Excel because it's not an Excel class. But if you have problem, you can ask me after this section. So I will skip this because the data will receive every minute. So what should we do when you plot it? Do you know how to make a plot? Click Insert, and we create a scatter plot. Yes, like this. Use this is the line curve. Of course, you need to adjust the size, the labels of the axis of your style you like. You can have this kind of plot. Okay, I think it's not that difficult. As you see that in this particular light, you see that the light curve is not interesting. But you see that there the twilight, the effect of the twilight. You see that the sky getting darker and darker after the sunset and before the sunrise. And so there's some influence probably from clouds. If you want to study only the period within the astronomical dark period, you can limit the display of the x-axis so that it will only show this portion of the curve. So we move on to another examples. This example is a little bit details because if you want to study the long-term time variation of NSP, what do we mean by long-term? In the last example, we show the light curve of a single light only. If you want to study the long-term variation of NSP, that means how could be the NSP change every light? We use the number to represent the NSP value every light. You may use the average value. So we got a lightly average NSP value of some station to study the long-term variation. So that in this example, I define the time period is something like this, 2 years ago. And the time windows is like this, from the 8 p.m. to the 5 a.m. in the morning. Please note that this time period I checked before is within the astronomical dark period. You should check this before you make a decision. Because we are studying the lightly average light sky brightness, so we should make sure that within this time period, the data were not affected by sunlight. So in this example, the time period will be 8 p.m. to 5 a.m. the location is HK2, and unfortunately, the emitter cannot do the job for this example. It can't calculate the FH NSB just by simple commands or using the predefined functions. So what should we do? I'm not sure whether you are familiarized with the MySQL commands shown here. Actually, if you can take a course on the usage or the how to use the MySQL, but I won't do this now. So I show you a campaign for you to do so. If you have time or you have an interest, you can study the code or other reference by yourself. But this code means nothing. Just tell us how to calculate the FH NSB from the data. Okay, actually you can do this in other ways, such as you can do this in Excel, setting some commands or functions. But I like to do this in MySQL because it is easier and faster most of the time. And please note that this example, if you want to study the likely FH of some station, and that means you have to consider the light curve every light. You have to average the NSB reading collect from single light, right? So there is a problem with the date, because normally the midnight, after the midnight will be another calendar date, right? So in this database they store the data in local time or UTC. That means most probably you will got a change in calendar date if you observe the light curve are full out a light. So you have to make some things to adjust the time code so that you will get the average reading across different calendar dates. So we do this, and if you download the program book from our website, you can copy the code from the PDF and paste it into this interface. Let me show you. And this is the program book, right? So you go to the slide of this section, where page 35 here, and you copy this part of code. So what should we do? In this table, you select the data table and then SQL command here. So you have something for you to type. So you paste the code in the example, paste the command, then click execute. Oh, why we have error? Because in this table, this line tells the machine to look for the table from this table, look for the data from this table. But actually, this not the one we are using. The one we are using have a name called training. I do this because in the future you have the real database without the name training. So in this case, you should add the training here, then execute. Then what you get is it will show a list of likely FH NSB like this. In this table, this column tells you the date and the location and the FH NSB like this. And the STD is called standard duration, 1 standard duration. It tells us the spread of the data within that light. It tells us how the fluctuation of the light curve within this light is sometimes useful for our analysis. It gives us some error in some sense. So the sample size tells us how the samples within this for these two values. And since I defined the time period for October, so we see that from 1st October to the last day of October. So this is what we want to know, the likely average of NSP within that period and that station. So let's, similarly, you click export, then choose save as CSV. Then we got the data. So about here. You see? So you can, it's up to you to use your software for plotting, but I can show you in Excel as well. So we want to plot the likely average of NSP. So the x-axis should be date and the y-axis should be likely average NSP. Like this. We got this kind of plot. Something like that. But please note that since the effect of the moon has not been removed yet, we just select the astronomical data taken within the astronomical dark period. But the moon may be affect your data properly because it's the data cover a month. So, but this is I will not discuss how to remove the moonlight data from in this section. As I said yesterday, you may track the lunar properties before the analysis and define some time period. If you want to do this you can do this by MySQL command, but it takes a little bit more details, or you need to define something else to define for the moon properties. But I can't tell in this section. So if you want to study the light curve or at another location between something else, you should modify the parameters shown here. Okay. Or if you are smart enough, or you have some experience in MySQL, you can define your own code, own command to fit your situation. Any questions so far? I think all of you can log into a database, right? So it is interesting if you have the real data. You see the real data coming. You see, you can analyze the light curve as in the morning, the light curve of last night in the morning every day, and study and study the light pollution condition. So in the last example, I will show you how to. I will mention how to analyze the data come from different locations. They are so-called cross-city analysis. That means your analysis is not limited to single location only. You can compare the light curve between locations. So the idea is the same. We should repeat the step. So here, example 3. If you want to compare the light curve within a single light from different location. So I don't have time to show you all the steps, but you can just use the details shown in the example 3 for another location to make the light curves. But please look at, as I said before, the effect of the moon and cloud were not removed yet. So in some case, you may have wrong conclusion. For example, if you find that the station A is brighter than station B, but you check the cloud data somehow you find that station A was cloudy, station B was clear. So you got a conclusion that station A is brighter. Is that correct? Yes or no? Because you know that the readings will be affected by many factors. The amount of cloud will increase the cloud brightness or even decrease in some dark places. And so, in addition to the contribution from the human lightings, the cloud will brighten the night sky. So, if you want to compare the light pollution condition between both stations, you have to make sure that they are connect under the similar cloud condition, right? So similarly, for the moon, if you find that station C is brighter, but you find that you compare the light curve of different days, so the data taken for station C, station C was for full moon, and the data taken in station D it was in new moon. So you got a maybe we got a wrong conclusion if you forget the contribution from the moon. So I can show you an examples of cost-city comparison. Actually, Dr. Boone showed this plot yesterday, and the x-axis is the time in local time, and the y-axis is NSP. In this graph, I have 4 light curves from different locations for the same evening. See that the red curve comes from the urban location in Hong Kong, and the blue curve comes from the rural location in Hong Kong, and the green curve comes from here, and the last curve comes from Taiwan in Shenzhou. And you see that for that evening, let me see, if we track the light curve from urban Hong Kong and rural Hong Kong, you see that the differences is quite large, right? Why? The light pollution. The population density or the lighting density in urban is of course greater than that in urban, Europe. So you got a brighter light curve in urban. But you see that there's a dome within this time period. What's that? They are the contribution from the moon, right? Because that evening, there was a moon in this time period. So for these 2 locations in Hong Kong, we see the effect of the moon. And for the site in Shenzhou, similarly, there is a moonlight effect. So if you want to compare the light pollution conditions between these 3 locations, what should we do? We should avoid the effect from the moon by consider the light curve in this period only. Why? Because after this time, the moon has gone. The moon set time is around here for all locations. So, and for this part of the light curve, this part of light curve were not affected by the moon. So lastly, for the light curve here, connected here, you see that can you see the moonlight effect? The green curve. Not at all. Why? We believe that the clouds cover the moon. So the moonlight can't reach the sensor. I don't have more evidence for this, but it's from my past experience. So if you want to compare the light pollution conditions of any object here with other location, can we do that from this light curve? Yes and no. As I said before, the light curve will be polluted by the contribution from the cloud. So For the rest of the location, this seems to be clear because we see the effect of the moon clearly. So we can't compare the light pollution in here with the rest of the location from this data only. So Albert Koch has shown us that there is a drop in NSP due to the turn off of lighting near the observation site. So we see the drop here. Actually, you can compare the size of the timing of the drops in some situation, so that you can know the switch off or the lighting, the use of lighting near the observation station is interesting. Yes?
But then, when doing comparison between different locations, we have to manually adjust with respect to the time zone because you are using the local time, right?
Yes, thank you for a reminder. Actually, this plot is present in local time. That means we got the data from the field called receive adjusted. Because that field was adjusted by time zone. So it's meaningful. It's only meaningful if you compare the light curve according to each local time. So otherwise you got a wrong conclusion. So we do this. So in this comparison, you see that the effect of the sunlight, is there any effect for the sunlight? It's a question for you to think. Sunlight or cloudy or clear, as I said before, you have got some ideas on the cloud conditions. And the moonlight, how about the moonlight? And you can get some conclusion, you can draw some conclusion from the light pollution conditions between urban and rural. And how about the drop of the light curve? And is there any holiday effect? Because you see that it's the evening, the New Year Eve. Someone will turn on their lights later. So that's all for my section. Is there any questions? Yes?
I have a question about this graph. How to consider about moonlight effect? Because sensor depth from the window maybe affects by moonlight from the side to side to control the
Yes.
length of the.
Yes, this is a good question. And if you remember, yesterday I talked about the light attenuation of the glass window of your housing. We are going to use like this. The scale sensor looks through from this window. So there should be some reduction in the light received from the sensor. Yes, we know it. And in this case, since all these four locations were the data taken from all these four locations were using the same housing, so we expect that the offset will be the same. So the same, because we use the same housing across these four locations. So if you take it seriously, you can offset the light attenuation by some small amount, say 0.1 magnetic per second squared for all this data. But in this case, it's not a must because all the housing are the same. So if you want to compare the relative light sky balance among this station, it's okay.
About the location of the window, because the sensor is offset is scattered inside the case. So if the rotation is,
It makes some difference. So so it's important for you to mount the sensor within the housing carefully, so that there's no gap between the sensor and the windows. Remember, you feel something within the housing to make sure that the sensor is in the right position inside the housing. You see? Of course, there will be errors if we mount the sensor not in a very good way. Maybe someone mount the sensor like this, not points directly to the zenith. It will affect the data. So if you know the problem, let us know and fix it, and let us know by making a record in the long night sky event. So it is important for all of us to maintain maintain a good record for long night sky event and increase our quality of data analysis. So.
Okay, same station on time. Surrounding or observatory. If moonlight is size is different,
you mean if there's some artificial light coming from different direction and scatter around inside the housing?
It's different from the picture.
Yes, it may happen and hard to tell because it depends on the setting or the environment of the observation location. So as far as I know, the sensitivities of SWLE sensors drop significantly away from the zenith, about 30 degrees away from the zenith.
But moonlight
Yes, moon is another problem. From our past experience, we find that the moon will make some differences on the readings, even though we have two sensors installed in the same location. And we find that the data was not the same, just because of the contribution from the moon. Yes? So I suggest you to remove the data taken moonlight before the analysis to eliminate this type of error. Okay. Or you can study how the moonlight affects your data using different orientation. Or you can point the sensor a little bit off the zenith and study how the sensor will, how the reading will be affected. Okay. Thank you very much. I wish you good luck in your data analysis. I'm looking forward to see your findings, maybe in the workshop next year. So next year, I'm the listener. I will not stay here to speak because I want to listen to your presentation. Thank you.